Welcome to the videos on electrostatics. In this video, we're going to be talking about the force of attraction.
Seal with a righteous kiss, a dateless bargain to engrossing death.
Whoa, gross. No, not that one. Roll the intro.
Do you feel the vibes?
We're going to be discussing the electric force. Now, when I say force, you may immediately start to think,
I have no memory of this place.
and even though this is our first video, it may elicit a reaction like,
Fine. Hey, listen, I quit.
and while,
I love a good quitting story.
just hang in there and pretty soon you'll be going.
I can do that.
Now, in mechanics, we already looked at one type of attractive force. Gravity is the attractive force between objects with mass. If you recall from the gravitation unit in mechanics, the force of gravity is equal to the negative of the gravitational constant times the two masses divided by the radius between the two objects squared. The negative sign here indicates that this is an attraction between the two objects. In electrostatics, we're going to be looking at a similar attractive force, but instead of it being between two objects with mass, it'll be between two objects with charge. So in order to continue this comparison, you can think about orbits as, orbits of electrons around the nucleus of an atom, where we have a negatively charged electron and a positively charged proton. This idea is represented in Coulomb's law, where the electric force is equal to a constant K times the charge of one object times the charge of the other object divided by the distance between them squared. Notice that Coulomb's law does not have a negative sign in front of it. That's because charges can be positive and negative. Opposite charges attract, so when you have one positive and one negative, you'll end up with a negative sign in front of the equation. That gives you an attractive force. When you have like charges, either two positive or two negative, that creates a repulsive force. They'll push each other away. This is a statement of fact in physics when it comes to charges, and is only applied in physics when it comes to charges. Please don't try to apply this to other aspects of life. It doesn't work. Now, we have a very strong disclaimer here. People use Coulomb's law randomly to try and dictate who people should date, or to say that you should be attracted to somebody who is very different from yourself. And while sometimes that works, other times it doesn't. This law is incredibly based on physical principle and not day-to-day life experience.
Nobody cares. Nice hat.
So ultimately, please ignore Coulomb's law in your dating life. Disclaimer over. Now, aside from the negative sign being an obvious difference between the gravitational force and Coulomb's law also has quite a different constant in front. While the gravitational constant is very small, Coulomb's constant, K, is actually quite large. That's because charge has a significantly larger effect on force than the mass of the object. It comes from radiative and spherical geometry, combined with the idea that the effective charge changes based on the material that the charge difference is passing through, or permittivity. To get the base form of Coulomb's constant, we use the permittivity of free space, or epsilon naught. This number is very small, which then makes K very large. Now let's take a look at charge. Charge, Q, is a physical property of the material that causes it to experience a force when placed in an electromagnetic field. Now, I know that doesn't really explain what charge is, and that's mostly because it's kind of a nebulous thing. So instead of defining charge by what it is, we define it as a physical property based on what it does. Charged objects still have mass, still have shape, still have all the other things that you associate with an object. They just have this additional quality about them called charge. Note that objects without charge are not affected by an electromagnetic field, and therefore are not subject to the electromagnetic forces, or in this case, Coulomb's law. When solving Coulomb's law problems, all you have to do is treat it like a normal force. Not the normal force, but a force that you are used to using. You calculate the magnitude of that force using the magnitude from Coulomb's law, and you calculate the direction based on whether the force will be attractive or repulsive. If it's attractive, then the objects will be pulled toward each other and feel a force as such, and if it's repulsive, then the objects will be pushed away from each other and will feel a force as such. And that's it. If you've forgotten how to do force problems, I'll link my forces playlist down in the video description below, so you can check that out. And that'll do it for this video on the explanation for Coulomb's law. If you like this video, please don't forget to leave any questions you may have down in the comments, or if you're in my class, you can ask me during class. And, comment, subscribe.